You're listening to Data Center Therapy. Please take a number, and an engineer will be right with you.
Good day, everybody, and welcome back to yet another episode of Data Center Therapy by Ivoxy Consulting. I am your host, Matt Yeti. I'm here now joined again by my co-host, Matt Cozzolino. Mr. Cozzolino, how are you today?
I'm wonderful. Getting over a cold last couple of days, but much, much better.
Yeah, we pulled the ripcord a couple days ago on the original plan for this recording. You did not sound good, but you sound...
I got a kick in the pants. It was horrid.
I'm glad that these things are recorded virtually in most cases. Sometimes we're in person, but I would have definitely banned you from the premises should you try to show up. You sound much better today, by the way.
Thank you. I did I did that with a customer too. I'm like, hey, so how about we work remote this evening because you don't want this.
I'm in my quarantine tent. Better if I don't come on site.
Exactly.
Well, we have a really, I think, on the edge topic right now. Most people might have heard of this, but maybe not gone too much farther than looking under the covers. But we're going to talk about containers. Now, the topic that some people might associate this with is Docker. It's important to note that Docker is maybe the most, it's Kleenex to the tissue. Is that right, Matt?
Yeah, it's the Xerox to the copier machine.
There you go. Right. So we're talking about containers and containerization. And Matt, Mr. Cozzolino has done an awful lot of this in his own personal lab and has extolled the virtues to me endlessly. And like the typical curmudgeon that I am, I've given him a bit of pushback, and I always love, he'll say, I love to play devil's advocate. And I embrace that role. Would you say that? It's true, Matt?
Yeah, I would. That is Yeti.
But it helps me understand, because if I challenge you, yes, this is good because it's blue and it's green and it's yellow and it's got all these things, and all I want to know is how is this going to be a better way for me to do what I already have to do and know how to do and have a good grasp on how to do. Mm-hmm. So like I've railed so much of our industry as here's this thing and it's different. See, aren't you? Why am I celebrating it being different? I don't want to celebrate different. I want to celebrate better.
Right.
And I feel like we're being sold different as this great new thing, and I don't really get that.
Yeah. I think that's where one of the things that happens is a lot of being in the industry and talking to the vendors, a lot of them are sell this, sell this, sell this, sell this. And the part that we see is most of our customers have that standard IT shop. They've got the Windows VMs, they've got the Windows OSs, and they aren't like, they're doing exactly what you're doing. What is containerization going to get me? Why do I care about this? And everyone's focusing over here and they're missing what we're dealing with. And that may mean that we actually need to kind of shift where we're going with customers and what they're trying to accomplish.
Absolutely. And you and I both come from ops, so we know what it means to have to, the responsibility of managing an environment. And so the idea of taking your 50, 100, 500, 1,000 VMs and having to juggle the requirements for keeping that up and available for your, and improved, right? Patched, upgrade, all that's entailed in operations. And now you're going to take that, and those responsibilities don't go away, but now you're also going to refactor those applications to work in an entirely different way. That's terrifying. So again, I need to know that's better for me to even think about tackling a project like that. So why don't you explain to me, Matt, the best you can, high level, what is a container? We all know what an operating system is and how to install Exchange running on Windows, SQL running on Windows, Apache and Nginx running on Linux. It's all a thing. We all understand that. What's a container?
So I just did a event with Google and Palo Alto, and they had a great little slide on that. And their slide showed the progression of, back in the day, it was I have my physical server, I install my OS on it, I install my application dependencies, and then I install my application. Cool, great, this whole thing works. We move forward a step, we install a hypervisor. Now we don't care about the hardware, and the app, the service we're providing is now an OS, application dependencies, and the app. Move forward another step, we're into containers. I don't care about the OS. My container, the bit that I run, the service that I'm deploying, is now application dependencies and the app itself. So it's kind of moving down that
The obfuscation layer, right? You were obfuscating hardware with virtual machines. Now you're obfuscating the OS within the virtual machine, or not a virtual machine, the OS itself. So you're obfuscated now. Now instead of your VM/OS being your object, your application's your object, and the underneath layer is obfuscated.
Yes. Yes.
Okay.
And so the big thing that brings, the biggest benefit that brings is now I have an ability to strictly version control an application I deploy. What we didn't have before, if you brought up Exchange a little earlier, the piece we don't have now with Exchange is when I want to do a firmware upgrade, how do I do that? I download an ISO, I download a pack, I install it on this machine. It goes and touches some bits over here in the operating system, updates some bits over there in the OS, and brings this app up a level, and hopefully everything came with it and everything works now. What happens when Java clobbers something else and breaks a thing? That's where this container piece is solving that.
Sure, and that sounds like a noble goal and,
Mhm.
and a good goal, quite honestly. I feel like in a lot of ways we're still in early days, and I think you'd probably agree. I think Docker itself, which is basically, would you say a packaged version of containers where it's got hooks into down like a repository? Is that what when I talk about Docker, when I hear Docker, is that essentially an implementation of containers that is kind of a whole polished storefront of it?
Um, yes. There is, just like with, if you're familiar with any of the Linux distros and you want to, I'm Ubuntu. That's kind of where I've lived for most of my time. It's the apt-get, and if I want to download this other package, I throw a URL, apt-get, learn this URL, and now I can go download that package from that store. It's very similar to that in the way
Okay.
that it works from day to day.
Well, so containers have been around, from what I understand, for quite a long time. Where LXC was a thing for, gosh, I think decades now at this point, right?
Uh, yeah, it's been a while. Kubernetes is the other one. Google started with that. When they started doing a thing, it was actually Borg was the OS, but they started Kubernetes, and that was all strictly around how do I manage containers. So when we talk about Docker, it's that same thing. It's the Xerox, but it's container as a concept has been around for a minute.
So I'm Mr. Scared Administrator, and I am playing a role when I say that, but in the same at the same time, I'm kind of being honest.
Mm-hmm.
I and you and I have had this conversation offline. Sometimes I wish we could we've talked about this. We could just turn the mic on and go because it's absolutely raw and real and authentic. But you were like, oh hey, we both run Plex servers where the media is shared out, or we catalog our media, and you are screaming, hey, I can just deploy a Plex Docker app. And I said, hey, that's great. How do you troubleshoot when something's wrong? I can just go to the log file, spit it out. I can go change the config file if I want. How the heck do I do that when these little Docker images seem to be these little black boxes that are running on top of the OS, and now it's no longer an environment I can shell into and work with. Now it's this kind of ethereal thing that's just, we know it's running, and how do I fix that when something goes wrong with it?
So that is 100% the thing that Docker does and the thing it does well. The fix and troubleshoot a thing isn't anything you do anymore. If there's an issue with the app that's running, it's because the container had some problems, and so your solve for that is redeploy that container. The benefit of containers is version control. Absolutely 100% version control. I develop an app in a container and give it these dependencies, and I install this and I get that and I build it and I put it together, and it's done. It's a fresh, clean install. Here it is in its entirety. It's good to go. It's a known good image of that instance. If in the course of operations something goes wonky with that OS, with that software, with the way it's running, something got updated automatically because I forgot to turn off a whatever, the solve for that is down the container, destroy it, and redeploy it from that known good point. We've taken...
Or if I want to make a change, I don't change it in the running Docker. I take the source control of it all. I make the .conf file. Let's say I have to edit one of the, I would edit that in the source, create a new version, and then redeploy it.
Yeah, you just and that's the same kind of thing we'd run into with our normal air quotes administrators is they don't do that. They aren't on that dev side, and this is really driven by dev. You would fork that. Yeah, go ahead.
Obviously, dev is a thing.
Mhm.
I hate to like kind of shove it over there in the corner and say yes, but. And I don't mean to denigrate develop in DevOps because my goodness, it runs so much of everything.
Mhm.
But if I'm Joe System Administrator, and I run a company with 150 VMs,
Mhm.
chances are we don't have a dev shop. Or what if I have a company that we don't make products, we don't make software or something like that, where everything we run is a third-party vendor that's packaged, and we buy software, we buy stuff from Microsoft. So I'm still troubleshooting 99% of my machines. Is it going to be a slow march to this? Is this something that I'm just going to have to eventually put in my quiver? Because it really kind of is a paradigm shift in how to break fix and upgrade going forward.
Mhm. I absolutely think that's something that'll have to be added and learned and understood. The other thing that kind of goes along with why containers are cool and great is you have the ability to spin them up for the need and then destroy them. So when you talk about cloud native apps and that ability to scale, they're really what's driving all of the cool stuff with containers. Is that I'm Netflix and I need another process to do transcode or whatever. I just spin up another container, throw my data at it, let it do its job, and then destroy it when it's done. Right?
Well, I think the key here is, like you said, that portability, the cloud native. You just hit the magic word there.
Mhm.
Right now, if I have a VMware VM, a Hyper-V, whatever I'm running a VM as, and I want to run it in AWS, what do I have to do to get it to run out there first thing and foremost? After the data's out there, what do I got to do with it?
Well, you have to have somewhere to launch your container. So AWS also has.
No, forget container. I mean, let me just say right now, you've got a VM, right? You got a VMware VM.
Mhm.
How do I run that in AWS? And I'm not talking about VMware on AWS. I'm talking cloud. When you said cloud native, what do I first have to do?
So let's define.
I have to create an AMI, right?
Sure. So an AMI or an EC2 instance is a VM
Right.
running on AWS. But
I guess sorry, I set you up without giving you the punchline. but that's my point is that that's not a cloud native process right now.
No, that isn't.
And so what you're talking about is, go ahead.
Right. So to your point, how do I run that VM? You need to just set it there and you need to run it. It runs as a machine. It's got the whole OS and nothing is fancy about it. It's just like running it on-prem. Getting back kind of to the container piece and what does that mean as an administrator? If we take our example, if we take Plex as an example, Plex is right now version 10, right? And they roll out version 11. I can go to my deployment, which says, here's where I want you to keep your config. Here's where I want you to do transcodes. Here's where you get your media from. Here's the last line that says what version of Plex you're running, right? So if I have an issue with that, I delete my container and redeploy it, and it's still version 10. If I want to upgrade, I delete my container, make a backup of my config that tells Plex how to work, and change that bit from 10 to 11 and redeploy it. If I have an issue, I delete it, change that bit from 11 to 10, and redeploy it. And I've stepped version control. There isn't. I'd ask you that same question. If you upgrade Exchange to whatever newest version is, and there's an issue, and you want to roll back, how do you roll back?
It would be uninstall the patch, which could be a mess.
Uh-huh.
I tend to go a bit hackneyed with it, but take a virtual machine snapshot prior to any upgrade, right, and roll back to that.
Exactly, because your snapshot is, I know this thing is running. in a good, consistent state right now.
But here's the thing: you can't keep that around like a Docker distribute, a version.
Right,
Because
exactly.
you have to vet that new patch ASAP and dump that snapshot. You can't leave that hanging around for a week or two.
Exactly. Whereas
Okay.
if in a week or two I run into an issue and, hey, you know what? I really do want to roll back. I delete my container, set the version to whatever I want it to be, and redeploy it.
Okay. Yeah, I mean, I'm not even knocking it. It just sounds scary to me from an ops standpoint. It just sounds scary because whoa, that I almost have to start from scratch in my understanding of exactly how I'm going to manage my environment now.
Yeah. It kind of like with that with what I was talking about is how it progressed. It kind of takes that same kind of approach as when we first really started virtualization. I used to have, here's my physical server and here's what its job was, and now I don't do that. I buy 3, 4, 6, 10 hosts and install ESX on them, and I don't really give a crap what they are. They're my compute, and they just do a thing.
So right now you have a Plex Docker image running in your home lab, and it runs presumably with Ubuntu under the covers as the base, quote unquote, hypervisor. It's not a hypervisor; it's a container base OS, right?
Yes.
Can you take that Plex image, push it over your tunnel to Azure, and will it run natively without any conversion?
Yes. So to qualify that, I'm not going to take the Plex image and push it over. I'm going to the whole thing about containers is there's literally a line in there where I say, here's my config. My config maps to this folder because in this context, Plex it actually has running OS config data that I care about. Here's where my movies live. Here's where my TV shows live. Right?
Right.
So that is state data about the application that is unique to me. That lives outside of my container. Okay?
Right.
So I want to run this in AWS. I have to be able to provide a couple of things. I have to be able to provide that config to my container. I have to be able to provide whatever other dependencies it needs. In this case, a shared folder with movies in it. If I can provide those two things, then I just tell my container service in Amazon, my container service in Google, my container service in Azure to run this container with these appropriate fields mapped, and there it is.
So that is truly cloud native at that point.
Uh,
I mean that's
Sure,
that's
sure,
kind of a
yeah.
statement. I would claim that.
Yeah.
So to this point, we've talked about Linux, and given that Linux is free, as in beer, all right, it's something that there's no licensing concerns, this or that. Windows obviously is a different ball game. I know that Microsoft, and I got to be honest, I'm a little behind on this, but how does that work when I'm a sysadmin in ops and I've got 99% of my machines are Windows? How does any of this affect me right now?
It doesn't. It isn't. Containerization isn't something you can apply. You can decide that, hey, you know what? I'm going to do that because it's cool, and now I'm going to take all of my stuff and convert it to containers. That's not how it works.
Right.
What it does is it gives you the ability to say, when I want to deploy this new service, I'm going to choose this service over that service because I can deploy it as a container.
So the developer of the app needs to containerize it. It's not something you can take a legacy app and munge to fit it into a container right now.
I hate saying can't, but for all intents and purposes, yes.
Well, I mean, you're from the Linux world where you can
that.
pull down a GitHub repository. You have the source code, so you can do whatever you want with it. A typical Windows app is not going to be distributed and shared in the same manner, so it's more black box kind of thing. So you would need the source to be able to refactor it, correct?
Right. I mean, because containers provide you the dependencies along with the application itself, you could, I think, air quotes, build this inside of a container and then deploy it as an image. I mean, I don't see
just
anything
wonder,
physically wrong with that, but
are we
it'd be
running
weird.
into a Java situation right? The quote unquote, oh, it'll run anywhere, but you got to have this version on this and this version on this and only run on this version. Are we running into that where the promise is, yeah, it's completely portable, it's detached from the requirements of the underlying OS? Well, that's not really true. I mean, it's not completely self-sufficient. It needs the underlying libraries to hook into the shared libraries. Um, I mean, are we running into another situation where, well, that cloud provider doesn't have Windows 19, it's got Windows 16? Is that going to, or Ubuntu 18 versus Ubuntu 16? Are we going to hit that scenario?
Um, I would liken it more to VM hardware versions, VM virtual machine versions, and how I can't run a virtual machine version 6 on an ESX5 server. It'd be more like that. Right?
Okay.
So if I deploy a new container app and it's built on all the latest and greatest Docker dependencies or whatever Docker has to have available to it, which I really don't see being that much, then I may run into an issue where my Docker 2 instance can't run my Docker 10 native image. But truly, I don't see that being
the goal is for it to require least common denominator type stuff, right? It doesn't want anything special. If I need anything special, I'll include that with the Docker image and not rely on the OS. Is that right?
That is 100% true.
Okay.
You may install Java on your Docker host for whatever reason. That is never going to get touched by the containers that you run.
Here's a weird question. It kind of getting into the weeds a little bit, not so conceptual, but actually practical application administration. But one of the things that I've run into a little bit that's confusing or ever is the network standpoint.
Mm-hmm.
The from what I understand, you've got a I'm calling it VMs because I think that's going to be the stepping stone a lot. I know the idea of containerization means let's get rid of your hypervisor, let's run a bare metal OS and then just run containers on top of that. That's a container is our new VM in our currently understood paradigm. But that bare server or that VM has an IP address, one.
Mm-hmm.
So I've got Docker apps that run even the same app. Let's say I'm a dev shop and I want to spin them up. How do I advertise those Docker containers or those containers on the network, especially if they share port numbers? Well, this seems like a huge conflict.
So, I mean, you can take that parallel and apply it to your existing ESX environment as well. And how do we address that? We give my host a separate management address, and then we spin up a container and give it a separate, or a VM, and we give it a separate VM instance on the network. Truthfully, 100% being real here, I haven't done that much with how the underlying networking works on the containers, other than, hey, I know that this port on my container is mapped to this port on my host, so that I can go 8080, 8081, 8082, and get my services on different ports.
Right.
There is some like east-west networking stuff on the container host side, but truthfully, I haven't done anything with that because it deploys and it works, and I haven't had the need to.
It almost feels like the paradigm shift that we're seeing with containers, the scale, the portability, cloud here. It almost seems like load balancers are now not a nice thing to have, but a thing you must have to manage all of this, because otherwise you're going to be playing DNS hell. You're going to be putting no one wants to put a port number in their URL.
Mm-hmm.
I mean, nobody wants that.
Right.
So I think when you've got something like an F5 or whatever in front, then you run it on whatever port you want. You don't care because the F5 is going to handle that based on the SNI, the subject name in the URL request.
Right. And that is absolutely what I do. That also gets me the ability to not really worry about my SSL piece on the back end, because everything goes through a load balancer and gets redirected HTTP to HTTPS, and then I can drop my wildcard cert in front of it, and everything's happy.
Which you would want to do anyway with a cloud native solution. You don't want to have to manually change your DNS pointers and all of that should you want to stretch to the cloud or migrate to the cloud. You want the load balancer to say, oh, this node's down, this node's up, and the access point remains the same.
Sure. When we talk about DR for a customer, here's a rubric, here's a Veeam, here's a this, here's a that, here's how I get my data from point A to point B. How do you get the users there? It's always DNS. You always got to muck with DNS to get users from point A to point B. That's still the case, and that's not going away, right?
Right, right. Well, I got to be honest with you, Matt. I'm a little more than intrigued. Usually, a lot of times I come away from our conversations almost hardened in my approach and my position. You might have delivered a couple of body shots today. I gotta be honest.
So it was. I've been running my Plex environment in a container for how long now? A year, I want to say. Just in the last couple of months, I had an update break Plex. I did my normal just shut it down because I've got the version set to latest. I did my normal shut it down, let it download the new bits that it needs, and spin back up and work. And it broke. It stopped working, and I went, crap. So what did I do? I went in and I said Docker stop, Docker delete, Docker remove, whatever the hell it is, and redeploy. Bam, there you go. I've got a text file that I keep in Git with all of my commands because I'm not fancy enough to have it all automated yet. Right? That's a whole nother thing. That's a whole nother topic. So it's Docker delete, Docker redeploy, and bam, it came down, and I said, okay, hey, look, it works. It's back. It's running. Everything's fixed.
So, okay, again, not wanting to let go of the old ways, hanging on for dear life.
Mm-hmm.
How did you troubleshoot that outside of, well, it's broken, I'm going to run what I know to be good? Because, you're probably like me. I like a little bit of, I like troubleshooting. I really do. And that involves log files, especially if you're in the Linux world.
Mm-hmm.
Can I still do that? Is there still a need to do that? I think there is.
Sure.
I want to understand. I don't want to just trust the Docker gods that this image somehow is magic and it works. I want to understand it at a deeper level.
There is. I mean, it's still an application running, and it's still running there. You can still exec into the container and run commands against the apps that are running in there.
So I can still do a tail or a cat on a log file by jumping into container and then running those commands?
Sure.
Okay, well that's a little Linus blanket right there. I feel a little better.
There's also we take a look at the app itself. What are you going to troubleshoot in Plex? You're going to troubleshoot stuff like how fast are my transcodes running? Do I have enough CPU available for that? And where do you find that? You find that in the application-specific log. Where does that application-specific log live? It lives in the config folder that I've mapped out to this other NFS share. So I don't have to go into the container. I go to this config where my logs are getting written to, and I just look at it there.
So like with anything, it's best not to just start ramming in Docker images. It's build your infrastructure for scale and for supportability. So actually, even though you're going to want the Docker as non-persistent as possible, right? All the persistent stuff, logs, configuration, you want that to be kind of hosted off a shared location that you can jump into outside the Docker container.
Yes. So I
like that.
So there's kind of like two ways to look at it, right? What we've talked about now with Plex and how that process is running is, here's this app that I need to run. This is way more like our standard traditional service that we're deploying. Here's this thing I need to run, and it needs to be consistent, and it just needs to be available 24/7, right? So I have a config, I have my logs, I have my stuff, and I need to save that somewhere. That's important. The other approach is the Netflix approach that I referenced earlier. I need another service to do a thing, right? So I'm going to spin up an instance. I'm going to spin up a container that's set up specifically to do this thing. Once it spins up, I do an API call, and I give it, here's the movie file that you need to transcode, and here's the source, and here's where I can get it from. And then I redirect my user to that thing to do its one job, and it has no state, it has no thing that I need to hold on to. And once it's done with its job, I destroy it and get rid of it because I don't need it anymore. Right?
Okay.
There's kind of two separate approaches to that. And truthfully, when I think cloud native, I think here's the instance that runs. Here's the web page you hit, and until someone hits that web page, it's strictly a HTML file with some code on it or whatever. And when you click that box on there, it spins up this other thing, and launches this environment, launches this container to provide you that service. And then when you're done, when you time out, when you leave, it destroys it and cleans it all up.
It's even more clear now that when people want to go to the cloud, and I think a lot of people, when they talk about that, they think they're just going to chuck their VMs up there and just run them up there, and somehow the world's problems will be solved and no one will starve, et cetera, et cetera. But I mean, one way or the other, there is refactoring that's going to happen, right? I mean, your infrastructure needs to transform, your applications need to transform. There is no quick switch to flip to get there.
Right.
I mean, this has been incredibly helpful for me. I hope anybody listening got a lot out of this too. I think it was pretty enlightening for a conversation. One thing that we haven't done in a couple weeks, and we will be getting back to full bore, is I've never seen that before. And we were talking, and neither one of us, on the spot could really come up. Matt, I got one.
What do you got?
I don't think I've not defeat, but I would never admit defeat. but that I've kind of been turned a little bit in my eye towards containers and their rightful purpose or practical purpose. When we get out of here and I get some time, I'm gonna dig deeper for sure. And I've got you to thank for that, Mr. Cozzolino.
You're welcome.
So I've never seen that before. Have you ever seen that before?
Yeti admitting defeat? Never. Not
I never. Hey, I didn't say defeat. I didn't say defeat. Well, I think that just about is a good bow to put on this one. Thanks for listening to yet another episode of Data Center Therapy. We at Ivoxy Consulting would love to answer any questions or have a dialogue about the cloud, about containers. We know you're out there hearing from the C-suites that, hey, we're going to be cloud first. We're going to move to the cloud. We have to explore the cloud. Let's have those conversations because there's a lot of gotchas in there, and we're not here to be boogeyman and scare you away from it. We just want a nice, sobering look at where can we improve our operations. And there is room for improvement in any infrastructure, and having those honest conversations is the best way to shake out where that improvement can happen. So reach out to us at podcast@ivoxy.com. Hit us at ivoxy.com on the website. We do free vSphere upgrade assessments if you want to get a feel for the kind of service we can bring and provide. And then if you've got any questions, like I mentioned, the podcast@ivoxy.com, topics you want to talk about, hit us up, hit Matt up, hit myself up, and we'd love to chat with you. Matt, do you have anything else to add before we wrap?
No, I think you got it all. Have a great day. Enjoy the weather's getting kind of nice.
Looking forward to that 60s and maybe even 70s. I don't want to get too greedy, but I'll take anything in that ballpark.
The time change. It was 6 o'clock and sunny last night. That was spectacular.
I'm loving it. Sunset after like 4 p.m. It's good.
Yeah.
It's good. Well, thanks for joining, Matt. This was a lot of fun. And for everybody out there, thanks for listening to Data Center Therapy. Have a great one.